Well, we've looked at polynomials of degree 2 and degree 1, which are the quadratics and linears. We're now going to look at what happens when your degree, which once again refers to your highest exponent, is larger than 2. Now, a polynomial is just a series of terms added together in which all the exponents on your variables are positive whole numbers. No decimals, no fractions, no negatives, and we don't want to have any variables inside of roots or in the denominators. Now, the intermediate value theorem states that if your function is at two different heights, your first height, your second height, between two different x values, then your function has to take on all the values between the two heights, between those two x values. Well, here are the two heights. Now, does our function actually take on all the values between here and here? Yes, and that happens from here to here. Takes on all those different heights between these two right here. Now, does this actually occur between the A and the B? Meaning your input for your first point and your input for your second point. Well, yes, it's in between those two horizontally. So does it take on all those values? Yes. Does it actually occur between A and B? Yes. Now, you may not think that's any real big deal, but this is what's nice about it. If you actually had a point below your axes and a point above your axes, so if here at B you're above your axes and at A you're below your axes, well, the only way to be able to go from A to B then is to actually cross your x-axis, which means there's a 0. And so the intermediate value theorem lets you know when you would have a 0 in between 2 points. Now, we don't necessarily know if it comes along and goes up close to B, or if it comes along and goes up close to A and then over to B, or it could be something in between where it could more or less be a straight line in between. Where in between A and B, we don't know, but we do know it does have a 0 in between A and B when you're one below and one above. So let's use our intermediate value theorem to be able to show that there's a 0 between our 1/2 and our 3/4. Well, to do that, we need to figure out what do we get for our output at 1/2, what do we get for your output at 3/4. So plug in 1/2 to your function, plug in 3/4 to your function. When you go ahead and plug in 1/2 to your function, you end up getting -8/9. So that means you have a point that's a 1/2 unit over and 9/8 down. Then we have f of 3/4. When you plug 3/4 into your function, you're at 41/28. Now, 41/28, that's going to be positive and above. So at 3/4 here, we're above. Okay? The main idea here is not necessarily that it's graphed extremely accurate, but that you realize that one is above and one's below. Now, if you're below here and above here, it has to cross somewhere in between here and here. Because we know it's a function, so we know it cannot go like this to get there. Because it would not pass your vertical line test. Or we would know it would not be able to go over here and then come back because it would not pass your vertical line test. Since it's a function, the only way to go from here to here and still have it pass the vertical line test is to have it cross somewhere in between 5 and 3/4. So that's what we basically want to write out. We want to write out and say that since at a 1/2 you're below the axes, and at 3/4 you're above the axes, we can say by the IVT, meaning the intermediate value theorem, that the graph crosses the x-axis, meaning has a 0 between 1/2 and 3/4. And you can anticipate having a problem like this on your test. So, we want to go ahead now and sketch this function. We want to find when our function is positive, when our function is negative. We've done some of that back in chapter 2. So all we have to do is basically set our function equal to 0, and we want to solve it. We're going to solve it, and then we'll put it on a number line. So we're going to go ahead and factor it. You'll notice that you could go ahead and pull out your greatest common factor of an x squared. Then you're left with a quadratic on the inside. If the quadratic factors, that's the easiest. If it does not factor, then you use your quadratic formula. So, in this case, are there any two factors that multiply together to give you a -4, but yet would add together to give you a 3? Yep. Your +4 and your -1. Well, you want to go ahead and set each one of these factors equal to 0. So what would cause this to be 0? What would cause this here to be 0? And what would cause this here to be 0? Now, your critical points are 0 from the first one, -4 from the second one, and 1 from the last one. Those are the numbers you're going to want to put on your number line. So you're going to draw yourself a number line. And now we want to decide whether we're positive or negative in between these critical points. So we're going to try a point over here, say -5. A -5 squared is positive. A -5 plus 4 is negative. A -5 minus 1 is negative. So we multiply across. Two negatives multiplied together is a positive times your other positive makes it positive. Now before, all we were trying to do is decide if it was positive or negative to go with our function. But here we want to just put down that yes, it is positive over there. Now, let's try something in between. We're going to try, say, -2. -2 squared is positive. -2 plus 4 is positive. -2 minus 1 is negative. Multiply across and we get a negative. So in between here we're negative, and we'll indicate that with subtraction signs or negative signs. Then we could try, say, 1/2. It's in the next region. Try 1/2. 1/2 squared is positive. 1/2 plus 4 is positive. 1/2 minus 1 is negative. So you multiply across and you get a negative answer. So you know in between 0 and a 1, it's negative since we tried 1/2 and we ended up getting a negative answer. Now we'll go ahead and we'll try a number over here on the right. You could try, say, 2, and everything ends up being positive, and 3 positives multiplied together is positive. So now we can go ahead and answer what's being asked. Now they want to know, when is your function being greater than 0? Well, that's where it's positive, here and here. So when is it greater than 0? Well, your function's greater than 0 when x is less than -4, and your function's greater than 0 when it's above 1. When is it negative, being below the axis? Well, that occurs when you're between 0 and -4 and 0 and 1. Now it also says we want to graph this function. Well, when we graph this function, we already have our critical points where it's equal to 0. So we'll plot those. Now, we know in between the -4 and the 0, we're negative, so we're below the axis. We know between 0 and 1, we're below the axis. We know to the right of 1, you're above the axis. You know when you're to the left of -4, you're above the axis. So then, we have our basic sketch. Here's your turning point, here's your turning point, and here's your turning point.